Ryan. I'm the host for the Applied Economics Skills Workshop, and this is our first one for the year. I'm really excited to have a past alumni of ours from 2021, Yifeng Lei. And today he's going to be talking about his experience working in Amazon for anyone who's interested in maybe doing the non-traditional academic route and going into tech or corporate world. So let's welcome Yifeng.
It's very nice to be back, and thank you very much for having me here. And thanks a lot for giving me the chance to sort of look back in the past 3 years since I graduated from here, and to reflect on what I have learned and what skill I have used in a tech sector. Although the original title was kind of focused on discussing the non-conventional skills, but as I make the slides and reflect on what I did in the last 3 years, my impression is a lot of the skill that at least are going to make you survive in a tech firm we already acquire. The department trained us, our PhD study trained us well enough to be successful in the tech sector. There are still some idiosyncratic like practice across team, cross firms that you wouldn't be able to know until you join the team, join the company. But majority of the things that make us be able to contribute are not that vastly different from what we do in a graduate school, what we do as a researcher. So I'm going to first talk about what economists do in Amazon. I'll give you some examples without disclosing the sensitive information, corporate secrets. Generally describe what economists do in Amazon and what I know that economists do in other firms that like Google, Zillow, and others. And I'm also going to talk about like skills we already have. You will see a list of the skills that is going to be useful, and you probably already have those. And I think that's a very good good news. And I'm also going to talk about some of the non-traditional skills. And then, because I guess people here are interested in working, at least considering working in the technical sectors, there are skills that you need to pass the interview. And I guess majority of us will be interviewing for technical roles. Typically after several years, when you make to like senior level in a technical firm, technical role, you can consider your path split into stopping individual contributor IC role into a manager role, either program manager or technical personnel managers. But before that, I imagine virtually all of us will be interviewed as a technical person first. And I observe a trend that is kind of, at least for my team, my entire org, about like 200 people, it's becoming a consensus that it's easier to make a technical person a manager. I'm not saying it's easy to be a manager. Being a manager is difficult, but it's easier to make a technical manager and make the team successful, and then making a manager a technical person. The latter is extremely difficult to achieve. However, majority of the technical team requires a manager that can be able to appreciate your team members' talent, appreciate your team members' effort in research, being able to communicate with your team member, and also serve as a bridge between your team member and your business stakeholder, internal stakeholder, to explain the research in layman's term, in a non-technical term, for your stakeholders. However, in order to be able to explain those, you still need those technical skills. So nowadays, the technical team managers are typically technical person before. So the entire team I am in were managed by a PhD in economics in Cornell, and my skipping manager was professor in Emory, applied economist as well. My skipping manager was a programmer, then become a product or program manager in Microsoft. So you see the entire chain of command are all previously technical persons. And I think that makes the team quite efficient compared to the others alternatives. Okay, so what do economists do in Amazon? Majority of the work we do is to convert a business question into an analytical framework. Business will ask an extremely vague question. For example, let's say the business is interested in making sure that we have sufficient number of workers that make the package every day. Then they will ask the question, so how do you answer that question? What advice you can do? What data you want? This is a question that without any, you can't even say this is a question. They just give you a scenario. Okay? Sometimes they don't even know what question to ask. That's a lot of the time is the challenge. Then you kind of can convert this scenario into saying, oh, probably your objective is to make sure that there will be always being X number of workers in each of the site. Had the probability of people showing up below the threshold become large enough, let's say 70% or 50%, you would like to increase the workforce pool. If that is your objective, you already you kind of converted their scenario into an objective, and then you do analysis of what is the arrival rate of workers every day. What is the probability of that the total workers arrive today is lower than the threshold? You calculate that probability. What data you need? You need number of workers every day. You need each site. The requirement of each site, how many workers you want. And then you conduct the analysis, probably Poisson, probably survival. Then you say, okay, these sites has the probability of achieving minimum threshold with probability of 80%, 70%, 60%, or some of the sites may have lower than 50%, then you advise increasing the pool. So you see the entire process is started with sort of a business described scenario, and then it becomes an analytical framework. The analytical framework is to convert the scenario into an analytical framework is your job. And also sometimes asking the right question for your internal stakeholder is also your job. And then you make research, and you do research, make concrete recommendation. Or sometimes it's a dashboard. You have a dynamic data pull in, you run the model, output, let's say, some elasticity, some marginal effect, and you make those into data visualization and present that data visualization to your internal stakeholder, to your business partners. They can look at this dashboard and know, oh, how far away are we towards the ideal scenario? How far away are we towards the optimum pool of workers, etc. So you see, this is kind of the contribution that economists do. A lot of the times is to use your knowledge in economic framework to be able to say, we have a way to answer your question. We have a way to phrase your question and answer questions. Then we conduct research, do report and report insights, and I said use data to advise business decision. And lastly, also very important and very challenging, and this is kind of non-conventional skill we need to have, is communicate with stakeholders. Typically, stakeholders are non-technical person. If you say, I need an instrumental variable, the person wouldn't be able to know what is instrumental variable at all. the person probably doesn't even know why do you need an instrumental variable, and probably doesn't know what is endogeneity issue. So you wouldn't be able to say this, communicate with a stakeholder in a technical way. You have to use intuition. You have to give a concrete example to what is endogeneity. Oh, you have X causing your X causing Y, and you have also confounders. And how confounders work to confound your estimate, and how do we use the instrumental variable to tease out the effect of confounders. So you have to sort of give them an intuitive description. And sometimes communicating with the internal stakeholder, meaning less is more. You give them too much information, they wouldn't be able to comprehend. In an academic scenario, we want to write as much as possible, so that by looking at our paper, our colleague, other researchers interested in the topic can replicate our work. However, sometimes I feel it's counterproductive to give the stakeholder all the information, because it's already challenging to read technical things, and you have so detailed information. It's very difficult for a stakeholder to comprehend. So what Amazon recommend is 2 to 6 page, typically 2-page summarize what the key findings, cut to the point. What is the question? How did we address it? What is the key takeaway? And what is our recommendation? 2-page summarize everything above. 6-page go to the details, and you can put everything you want in the appendix. Your internal stakeholder is not going to read it, but it will be a very good thing to document, and also in the future showcase to your technical reviewer when you try to get promoted. So you see a lot of the things I described above sounds like the rearrangement of your academic paper. All the information are there. You have conclusion at the bottom of your academic paper. Now you need to put your conclusion first. You have the ability to write abstract in a very concise way. You have ability to write extensive abstract in 2 pages, in providing a little bit more details. Now, the abstract or the extended abstract can be your first 2-page, and then you have your conclusion first, and then you have your method, findings, and all the details are in the appendix. So when I look back of my everyday work, I feel it's not that different from what we do as a research assistant in the U. And the works is just that the output format need to be adjusted a little bit. So the skills we already have, there's like econometrics, statistics, present the results. We go to conference, we present to a technical audience. Now we need to have the ability to present to the non-technical audience. We are accustomed to do research before we ask questions. Most of the times I feel everyone has a PhD degree tends to, when I have a question, my colleague and I tends to just research first. Then if I cannot answer all the details, I find an expert. I find it's not the case in everyday life. If you have a colleague in a business sector, they probably wouldn't do a very deep dive first. They will tend to ask you. They will tend to kind of find someone to explain things to them first, instead of like reading extensive long papers, search for like academic journals to be able to try to find information before asking a question. That's a very good habit, I think, for a technical role. You do your research first, then you ask. It's not only protect other people's time, it also reinforce our ability to find information. The new things and tools. you probably know nowadays everything is about machine learning, statistical learning. Machine learning, statistical learning, at least when I was in a graduate school, it was not like standard skill that economists need to have. But now it's becoming convention that anyone, regardless of whether you're a data scientist or an economist in a firm, you need to know at least a little bit of machine learning, being able to do some predictions with an elastic net, know how random forest works, you know how like boosting XG boosting those techniques works. Not necessarily to a detail that you can sort of write your own code and create a package, but at least be able to use those tools with a package in Python or R. So learn new things and new method is something that some skills that we are trained in a graduate school, right? We study our dissertation topics. We read papers, sometimes read papers 50 times in order to understand what they are talking about. Dissecting the code, download the appendix, read the author's code line by line, see all the details behind the paper. These are the very important skills that make you successful in a technical firm, right? Systematic thinking and based on economic framework, just like what I said, you transform very vague business questions into an analytical framework. You ask the questions that your stakeholder will be interested in, however, they are not able to ask because they don't have this mindset, right? You ask those questions for them, you transform those questions into a solid analytical framework, you do research, output, and do presentation. And then academic writing, we already have that. Academic writing is very systematic, very logical, right? You have very clear structure. All the structures are connected from introduction to the conclusion. Now, it's just that you may need to rearrange the paper for a broader audience, for non-technical audience. Now, you give them a brief introduction first. You give them clearly state a question, give them a brief description of what we did, conclusion, insights, takeaway, and that's for the non-technical audience. Then you go to the details to describe all the models you tested, all the sensitivity tests you tested, how data is structured. Not that different from academic writing, actually. And I mean, it's not surprising because academic writing is supposed to be logical, concise, and also being able to communicate with everyone, with the audience in an efficient way. So it's not surprising that academic writing is most of the time works in a technical firm. I can't say that I'm very good at writing. So this is what I feel, right? At least from my perspective, I haven't been very directly sort of someone says your writing needs to be significantly improved. I'm pretty sure my writing needs to be improved. It's just that my writing is good enough to communicate in the business sector. And I've been writing in the same way as I write papers. So that is what I feel. And also I get feedback from some of my colleagues that they like to read my report. They learn things from my report. So in my writing style haven't changed much. It's just that I rearrange what comes first and what comes next. Project management, typically, I mean, 3 chapters to perform your dissertation, and oftentimes you have other project for your academic advisor. when we're in graduate school, we probably work multiple projects at the same time. You already be able to handle multiple projects at the same time. In a firm, typically no one should take more than 3 projects at a time. The rule of thumb is manager will keep you have like about 1 main project and 1 side project. You wouldn't, for IC, you wouldn't need to worry about a lot of things. You wouldn't need to worry about like a lot of balls to juggle. However, when you make to the manager role, things get wild. Sometimes you have like 7 reports, 11 reports. You probably wouldn't be able to remember all of the project. That's normal, but that is something you need to worry 4 or 5 years later. I haven't joined a firm for 5 years later. I can't tell you what life is as a technical manager. So I can only speak for as IC. So the non-conventional skill, as I said, one is machine learning models. How many of you have used machine learning model in your study right now? Okay, so was it for inference or was it for prediction? Mostly for predictions. Okay, yeah. So prediction definitely learning some machine learning, the basic. I think there's a book by Trevor Hasty. So I think it's called the Principles in Statistical Learning. I recommend at least read that book from the beginning to the end to learn what options are out there. I think the author is Trevor Hasty. I can find it later. There's another 3. There are 3 authors. They are all in Stanford statistics department. The book is very good. Read those. It has practical examples how to use them in R. You can, I bet you can find corresponding package in Python as well. And nowadays, I think more technical firms is using Python than R. So if you have time to learn Python, I would encourage you learn it now. I'm not a very good Python code writer. I primarily use R. And non-academic writing, as I said, 2 to 6 page, being able to summarize everything, being concise, and sometimes you have to cut some of the information without mentioning some of the information, so that your audience being able to comprehend without like information overload. Stakeholder management is something that we probably never learn in the school. If you have like co-author, you probably have more experience, like interacting with the co-author, who does what divisional work. You have more communication skill learned if you have co-author. However, most of the time, I guess we write our paper individually. Stakeholder management in a technical firm is even more difficult. If you have a co-author, you can communicate in technical terms, but for the stakeholder, for the firms, you oftentimes need to deal with people from various backgrounds. Sometimes people not necessarily have a basic understanding of like linear regressions. They have no quantitative training. You have to use intuition. You have to use data visualization. Whatever skill you can come up with to communicate. So maybe I can give you sort of who are the internal stakeholders typically economists engage with. It depends on what department you get into. For example, if you go to HR, then you work with people do workforce planning. You advise optimal headcount. You advise hiring, who should be hired, what kind of background is more likely to success. If you get into a team in the finance, they will do headcount planning as well. They will do a lot of strategic planning, like suppose we have like 6 markets. Which market should increase investment? Where should we build the next data center? I'm in AWS, right? So AWS is Amazon Amazon Web Service provides cloud service. The cloud service is based on data centers. Every data center costs billions of dollars. This is open information. You can Google. And Microsoft, Amazon, Google are the top leaders in cloud service currently in the US. And how much service you can provide quite depends on how many data centers you have. Each data center costs a lot of money. You have to plan very carefully. So this is kind of some of the question that finance sector answers. They would like to know, where should I invest to achieve the highest efficiency? There are other questions, like if you go to advertising in Amazon, they will be interested in, there will be a team that deploys the advertising. They will be a stakeholder. They would likely want to know how effective each ads was. For example, if they have an initiative to engage, to bring in influencers, TikTok influencers, Instagram influencers, they will very likely going to be interesting how effective if I give investment to these influencers, how much sales I can get. So the internal stakeholder will be those who deploys the ads. It all depends on which sector, which department you get, you hired. But generally, internal stakeholders are non-technical persons. And I actually find it's sometimes better to interact with someone who is completely not a technical person, because my experience is that sometimes you engage with some as internal stakeholder that has some understanding of statistics, econometrics, but they will insist something that from academic perspective is nonsense. For example, they will ask you for causal inference, what is your error rate? This is a question that take a long time to explain. If it's prediction, you have error, you have a measurement of error, how accurate your prediction is. For causal inference, what is the measurement of error? Had I know the true parameters value, I wouldn't need to estimate, right? But this is kind of difficult to explain. If they know a little bit of statistics and machine learning, sometimes they ask questions that it takes a long time to persuade them. However, for non-technical stakeholders, I feel it's actually easier. You use more intuition. They will understand. As long as they understand your intuition, they are more likely to be on board. And the third and the fourth one is something that I think I learned the most, is the engineering skill. So what is engineering skill? It's like, so when we in a graduate school, we do research, and usually the research is one-time thing. You collect your data, write your paper. In a company, it's very rarely one-time thing. The data gets pulled in continuously. For example, like AWS. AWS provides services to all customers. The customer usage data is pulled in by seconds. At least you can get customer usage data every month pulled in as a batch. So it's very rare that in a firm that they were interested in one question and then you just drop this topic. If that is the case, then they wouldn't ask the question at the very beginning. It's a waste of time. So it's very likely they will ask the question, they will repeatedly ask this question. So to make your life easier, be able to reuse your code be able to rerun the entire thing and then produce the report without much difficulty, as long as you have a previous version, becoming very important. So engineering skill is like you be able to write reusable code. Your code is efficient. You trigger it, and it outputs whatever form you want, dashboard or reports, in an efficient way. This code can be run repeatedly, and sometimes you can even schedule a run for the code to run at every week, every 2 weeks, every month. So this is kind of the engineering skill. A lot of engineering skill depends on using some of the things that we probably did not use in a graduate school, like GitHub. Git is so how many have you used GitHub? Okay, nice. I did not use GitHub at all when I was in a graduate school. So very good, very good. Use Git early, being able to do version control. Being able, if you have how many of you have co-authors and you do code review? Oh, nice. So those are very good skills. Those are very important skills to learn. It will make you transition into your role much faster. Every company may use a different version of Git. GitHub has a very good UI user interface. Sometimes your company may just have a very simple. You have to connect to the server. You have to type something CR and then initiate a code review process. Whatever form, the foundation is pretty much the same. You have version control. You communicate with your co-authors, check the conflicts, merge the branches, commit, push. So if you know those functions, try to get used to it. And even if you're just writing your paper alone, you still try to create some branches, try to merge it into your mainline, and get familiar with those. And then there are other things like Linux. How many of you use the HPC? Okay, yeah. So I think the university has a policy that every professor has certain amount of computing time that can grant to the students. When I was writing my dissertation, I used HPC a lot because I realized my third chapter, if I do not use HPC, it's going to take a month to finish the code. So I asked my advisor for help. You can use a high performance computing in a Linux. You don't need to be very good at Linux. Just being able to say, let's say, create a directory, move files, delete files, trigger your code run. That most of the time that will be sufficient. You don't need a lot of Linux command skill, but if you can start using the HPC and get familiar with Linux, I would encourage you to do it early. And I mean, generally, data set in our study gets larger and larger. In the future, it's more likely that at some point you will encounter a very large data set to handle. However, there are a lot of tools out there to use. You can use Microsoft Azure, you can use Amazon Web Service server, you can use Google Cloud to pay a $10, $20, $30 per month if you need to get a very powerful machine. And that will make your estimation much faster, make your life much faster, much easier to do research. So very likely that in the future, you'll probably encounter some system constraints. Maybe then I would encourage you do it early. And then other skills like schedule cron job, CRON. Cron job is a Linux function that make your code run at any cadence you define. Then you have, if your data keep put in, you have this engineering skill, write your code in a reusable way, and you can schedule a cron job run at any cadence you define, and output the insights or dashboard. So it probably at this moment you realize a lot of the skills are not that different from what academic do. And I mean, it's not surprising because academic has a very high requirements, right? We have peer reviews, we have very complicated models. Most of the skills are already going to make you at least survive. I don't know whether I'm successful or not. I know I will know whether I'm successful or not at the end of my career. So I can't say those advice will get you successful, but at least they get you survive. And if you know that if you keep tracking the news, tech sector has multiple rounds of layoff. I'm still giving a presentation here, fortunately. So that probably means that my skill is it matches what Amazon is. So before you get hired into the technical firms, there will be an interview process. Most of us will interview for technical IC. What they care about are here. These are not secrets. These are something that you can find. You register a blind. Have you heard of blind? Blind is something that a lot of tech firms use. A lot of the information on blind are nonsense. Don't trust all of those, but sometimes they do give very sincere answers, like what do you need in the technical firms. And also Glassdoors and LinkedIn's. You can find all basically these are the technical skills you need to do an interview. I wouldn't be able to give you concrete examples. I'm not quite sure what I'm allowed to say those but general skills just there. So why do we need a SQL? Majority of the time when you get into tech firms, the data are gigantic. So far, most of the firms use SQL to handle. So we have Minnesota Population Center. They have very large data set. They have different ways to handle it. But what I see in most of the technical firms, they use SQL. I'm not sure whether NPC has a plan to switch to SQL, but I mean their system is very efficient. So they probably don't have any incentive to use a third-party tool. So SQL, you probably don't need to write SQL very well because it will. I mean, if you're interested in writing SQL, that's great. You like coding, learn as many languages as possible. But if you would like to sort of make it efficient, you can try use R's dplyr package. It's because our language is developed quite early. So it was developed at a time when SQL getting popular. And then there's a package dplyr based on a package that has like over 15 years of history. They just keep translating our code into SQL. So the front end is you write our code in the dply format, and then you translate the code into SQL and send the code to whatever SQL connection you have. I would encourage you try to learn a little bit of dplyr if you are a programmer. And the next one is also definitely Python and OR. If you are still using Stata, give it up. It's not going to get you very far. If you step into the labor market like 5 years ago, 7 years ago, you probably still make it using Stata in a technical firm. However, my experience is Stata is supported in Amazon. However, it's becoming less and less friendly. The environment become less and less friendly. One of the reason is because the need to productionize your code in Stata is quite difficult. Stata requires license, right? Stata needs corporate pay Stata. R is open license, Python is open license. When those open license language available, the programmers will be reluctant to prioritize something that requires a subscription. They will be easier to build R or Python into the system. You're going to use everything on cloud, right? So the cloud at the beginning is just Linux. They have to build the infrastructure to be able to use R or Python. They will always prioritize R or Python. They will prioritize Python. So the definitive answer is they will prioritize Python first. If they have time, they will do R. If they have time, they will do Stata, right? So if you're still using Stata, your priority is quite low. So give up Stata, unfortunately. And introduction and my advice is directly go to Visual Studio. How many of you use Visual Studio? Yeah. Visual Studio, very great. Visual Studio can do R, can do Python, can do SQL. So you just need a Visual Studio to do virtually everything, right? So one editor do multiple things, fantastic, right? And learn a bit of Linux command, as I said. There's no need to be most of the time there's no at this moment, I don't think being a very good being an expert in Linux is required. However, being able to say I trigger the code on Linux and repeatedly run the scheduled cron job. Yeah. And the last one is I think these are pretty much the things if you are interested in causal inference, you need to update. If you are I was hired as an IO economist, so IO is still discrete choice stuff, BLP models. As long as you know those, pretty good. I think it's sufficient. And trade models, gravity models, etc. Like conventional IO models, you need to know those. If you are in causal inference, I feel nowadays you need to update your information, update your knowledge if you haven't followed up with those techniques. Double machine learning basically combines machine learning and the causal inference, causal forest, and surrogate model is you predict the long-term effect with a short-term effect first, and then you use the expected value of the long-term effect as your y and do an inference on that y. It's called, and that conditional expectation is called surrogate index. Basically you do a causal inference on the surrogate index to evaluate a long-term effect. Recent development DID, because the two authors, Callaway and Santana, find the conventional DID in a staggered situation will be biased. So there's a recent development DID, and also other people has other proposed method, but this one is probably the most used one. And they have another version is for continuous treatment and generalized synthetic control. These are the things you should try to get familiar with before you go to a technical interview. How familiar? I would say at least write this paper to the point that you can explain to the interviewer in a clear language, in your own language, and at least tried one or two examples with package. Only this one doesn't have package. The others all have packages, right? But the third one is quite clear. You use a shortened outcome to predict a long-term outcome, calculate expected value of long-term outcome, and use the causal inference on that. conditional expectation. It's not very tricky. Yeah, so these are the things that I think will be asked in a will be useful in a technical interview. Yeah. So that's it. Yeah, 45 minutes. Okay. Thanks. Open for questions if you have. Yeah.
What do you think is the best way to find job openings from techs?
I have to say it's pretty random. So I can give you several examples that I have. So let's say so the Amazon has a application website. You can upload your CV and then batch apply. So you can just click apply all this at the same time using the same stuff. This is what I did, and somehow they give me an interview. To be honest, I was looking for academic job, so I was thinking, oh sure, interview, I just go try, not having a lot of expectation. But eventually, I did not get any academic university offer. I only get the two industry that I applied, Amazon and the Ford. So that, and then I landed into the Amazon. So if you ask me, sort of, is there any magic trick? I don't know. I have no idea. But I have friends who just follow the same process, get interviewed. 2 friends get interviewed. So following the same process of applying for a job and get an interview is not that difficult, I think. The difficulty is like getting an interview and then get to the second round and get to the third round. There's another way is that finding a Amazon employee to refer you. That is definitely very useful. I am not quite sure there's a limitation of referral, but I think it's 3. The number is 3, but how long, I'm not quite sure. What is a month or a year? I'm not quite sure, but at least Amazon employee would be able to refer 3 people in a certain period. Finding a referral is definitely increasing the probability of getting their attention. Other than that, I'm not quite sure. I don't think it's needed to like contact a hiring manager directly. You wouldn't be able to know who are the hiring manager either. And sometimes the hiring process is like central hire, and then you match with the team. It's not the team directly hires you. Sometimes it's central hire, and you match it with the team. So you wouldn't be able to know who will be your manager in the future. So summarize their website or find a referral. And you're probably interesting, like, what is the return to office policy? I think nowadays you probably can go to multiple cities, definitely more cities than the time I was hired. You can choose from most of the major cities, I guess, but at least like New York, Boston, DC, Dallas, Austin, San Francisco, Seattle, Chicago. These are the choices. If you negotiate, you probably can stay anywhere that Amazon has a office, but I'm not quite sure that is practical at this moment. The reason I get assigned to Minneapolis office is because I was hired in the COVID period. They had a policy of global hire, which is wherever there's an office, you can hire. I'm not quite sure whether that's still the policy, right? Return to office currently is 3 days a week. Yeah. So flexibility is still quite high. They don't require you like go to office for the entire day, but as long as you don't just constantly swipe in and swipe out.
Can you talk a little more about the interview process? Was there a code assessment and and if there was one, what was that like?
So interview processes, my understanding is for economist position currently, you don't need to write code and they assess you. It's not like programmers, developers. However, you need to be able to describe the code structure to a very clear way. Let's say what is the process of doing a discrete choice? Describe it, right? Linear utility function, linear indirect utility function. You have the V, and you describe all the exponential V divided by 1 plus exponential V is the probability you get chosen, and you have the likelihood function, and take a log of likelihood function and maximize it. So you'd be able to describe the entire process clearly to the interviewer. That would be a bonus. If your answer is just, oh, I use discrete choice model, probably the interviewer is going to follow up. Could you elaborate more? There will be no clear sort of, you need to write the code right now, but you have to describe to the point that they can clearly see you know how to write the code. And a lot of the times, if you interview for like causal inference, you probably wouldn't need to write your own likelihood function. You can say, you can use package. However, you need to demonstrate to the interviewer that you have a very clear understanding of what this causal inference do. For example, if you say, I'm going to use, you can try causal forest, then you need to describe how causal forest works. Each split into homogeneous group and continue splitting until the certain stopping criteria met. And then each homogeneous group gets a treatment effect, and you aggregate. So some of those description demonstrating you know the method well is definitely needed. You wouldn't be able to just get to the second round saying, oh, I'm just going to use a causal inference or DML. You need to be able to describe it, and describe it in an intuitive way is even better.